verifying trigonometric identities. Just a reminder that verifying trigonometric identities runs from really difficult to almost impossible, and this one is somewhere in between. Let me also remind you that when we're verifying trigonometric identities, almost always we're asked to transform the left-hand side into the right side. So this area here on the right that I have boxed in, we're not supposed to manipulate that. We're just supposed to keep bringing it down, and at the end, compare the left side to the right side, and hopefully they're going to match. So there are lots of ways to get after this, and I'm sure as I do this video or as you watch it, you're going to say, you know, I would have done it a different way. Please let me know what that way is, but be reassured that there are many ways. So I think what I'm going to do is, because so many of these are rational, I'm going to just go ahead and change them into different forms so I can get a better look as I multiply them, because I think I'm going to do FOIL here. So we know that cotan is cosine, isn't it, over sine theta, right? And we also know that cosecant is 1 over sine theta. And if this is not ringing a bell to you right now, then what you need to do is stop the video, go back and get your fundamental trigonometric identities, and there are 8 of them that come in 3 major groups. The first group is the reciprocal identities. The second group is called the cotan-tan identities. And the third group is the Pythagorean identities. So what I would do if I was struggling with these identities is I would just have that list with me, and I'd work from the list, and it'll start to sit in your brain. All right? So now when I open this up, and we know that tan, right, is sine theta over cosine theta, isn't it? And of course, sine theta is sine theta over 1. All right? So then I'm just going to do FOIL here. So I'm going to do FOIL, which is first outer inner last. So I'm going to multiply this times this is my first, and that would give us cosine theta sine theta, right? Over sine theta times cosine theta is still cosine theta sine theta, isn't it? Then outer is out here, right? Which would give us negative cosine theta sine theta over sine theta, right? Then we'll do inner, and as we do inner, we get positive times a positive is a positive, and 1 times sine is sine theta, so sine theta. And sine times cosine is cosine theta sine theta. And then we would do last, right? And last is a positive times a negative, which is a negative, and we get 1 times sine theta, which is sine theta. Sine theta times 1 is sine theta. Now this looks like hell right now, but sometimes if you just let it keep going, remember we're bringing this piece down. Sometimes if you just kind of go with it a little bit, all of a sudden the pieces come together. So look what's going to happen here. This is kind of cool. Remember that our goal is that this whole thing should equal secant theta minus cosine theta, right? Right? I just brought this piece down here. This is our goal here. Well, look at this for just a second. Cosine theta sine theta over cosine theta sine theta is 1. Right? Just going to keep doing my work. This negative sign is this one. Sine over sine is 1. Isn't it? So that's minus cosine theta. Right? Looking like it, isn't it? Here, this is a positive. Sine theta, they cross out. 1 over cosine theta is secant theta, isn't it? So 1 over cosine theta is secant theta, right? And look at this. Negative sine theta over sine theta is 1 equals secant squared, not secant squared, sorry. Secant theta minus cosine theta. Let's take a look. Going to cancel now, right? Going to simplify. 1, positive 1, negative 1 cross out. This negative sign, you guys, is this one, isn't it? So negative cosine theta, that's that, isn't it? And this is its negative sign. And 1 over cosine theta is secant theta. So check. All right? The only way to do this is to actually do it and to kind of work your way through the frustration, not give up, and to remind yourself, ask yourself questions. What do things have? What does the left and right hand side have in common? In what terms? Sometimes can the right side look be represented? And if you look here, this is secant, so this is in cosine and this is in cosine, isn't it? So That's another thing that you can think about. And always go back to your fundamental trigonometric identities. Try to get those things memorized the best you can, and I promise you, you're going to have a lot of success with this.